Okay, let's unpack this. Today, we're diving into a really cutting-edge concept, meta-temporal coordination.
Right.
Now, meta suggests, a higher level, temporal is time, and coordination. Well, that's getting everything working together smoothly.
Exactly. So we're essentially looking at a kind of master system that orchestrates things across, well, wildly different timescales and entities.
And this deep dive is all about how that kind of framework could really shake things up for future AI systems, especially those involving like multiple species or systems working together.
Think AI agents, humans, machines, maybe even biological organisms.
All acting together, like a complex orchestra almost.
Precisely. And our mission here is to explore how this framework, this metatemporal coordination, helps keep things running smoothly over time.
Yeah.
Maintaining continuity, keeping context clear.
And managing roles dynamically. We're drawing on theory, some recent research, and this is where it gets really interesting, right? How does this stop it all descending into chaos?
That's the core question, really. How it fosters a true collective intelligence.
So, first thing, sustained context continuity. You've got these incredibly diverse systems, maybe an AI processing super fast, a biological system reacting much slower. How does MTC keep them all reading from the same script?
Yeah, that's crucial. What's fascinating is that it acts like a persistent memory, a living memory almost, for shared goals, past decisions, all that accumulated knowledge.
So it's not just storing data.
No, not just a database. It's more about dynamic knowledge graphs.
Yeah.
They don't just hold information. They actively map the relationships, the dependencies across those different timeframes and system types.
Okay.
Imagine an AI in a smart city needing traffic patterns from last week, but also reacting to a real-time environmental sensor. MTC ensures they're both pulling from the same constantly updated contextual story.
Right. Otherwise, you just get fragmented views, conflicting action.
Exactly.
Okay, so establishing that shared memory, that continuous story is foundational. But systems evolve, capabilities change. How does it stop that memory becoming, rigid? Which brings us to dynamic role management.
Right.
How does this concept handle roles shifting over time, especially when things are changing so fast within the collective?
Well, this is all about fostering genuine, flexible cooperation. Meta-temporal coordination provides the mechanism to allocate roles and, crucially, adapt them constantly.
To algorithms.
Yeah, adaptive algorithms that are analyzing capabilities in real time. So, say an AI agent gets better at a task, or maybe a human needs to step in unexpectedly.
The system can just reassign.
Dynamically, yes.
Right.
Like a sports team, players shifting positions based on the game's flow. It prevents rigidity, encourages that flexible cooperation, and optimizes what the whole collective can do.
That makes a lot of sense. Real agility. Now, shared information is key. You mentioned knowledge graphs earlier. Can you expand on that? How does MTC create this collective memory beyond just individual data points?
So this is where those shared knowledge graphs, often centralized, really act as the brain of the collective. They're designed to pull in data from everywhere: AI analysis, human input, machine logs, even biological sensors.
Everything.
Pretty much. And crucially, they don't just collect it. They model the connections, the dependencies between all these different bits of information across time and system types.
So everyone gets the same big picture.
A common, always updated, deeply interconnected information base. It's vital for making sure decisions are aligned and informed. Think of it like a living encyclopedia that updates itself instantly and understands how all its entries relate.
Wow, that's powerful. And with all that info, you need solid learning mechanisms. How does it enable complex feedback loops and continuous learning across these really different entities?
By constantly capturing and integrating outcomes, what actually happened over time and across all the systems involved, MTC creates these powerful feedback mechanisms.
So it's not just raw data, it's lessons learned.
Exactly. Contextualized lessons from collective actions. Machine learning models within this framework then chew on this rich experience to promote adaptive learning. It builds resilience, encourages cohesiveness.
Learning from the whole group's history, not just individual actions.
Right. Which leads to much faster adaptation, hopefully.
Okay, so it helps systems learn, adapt, but these collectives are just inherently diverse, right? Unpredictable interactions. How does MTC actually manage that multidimensional diversity and stop it all falling apart?
That's a huge challenge. Theoretical work on multispecies cohesion helps here. It gives us models for how diverse entities can maintain stable, productive interactions over time, despite their differences.
And MTC uses these models.
It can, yeah, to sort of modulate collaboration timelines, synchronize key processes. It involves adaptive scheduling, dynamic resource allocation, all based on predictive models.
Yeah.
Basically trying to reduce chaotic surprises.
Okay, actively managing the complexity to get predictable, beneficial outcomes.
That's the goal, enhancing the desirable joint behaviors across all that diversity.
That's a massive benefit, taming the chaos. So finally, thinking about the real world. How does this support things like ethics, governance, long-term sustainability in these complex networks?
Yeah, connecting it to the bigger picture. You've got interactions spanning ecology, society, technology. MTC provides a structure to continuously integrate ethical rules, governance protocols, sustainability goals over time.
So the guiding principles evolve with the system.
Precisely. They don't stay static. The system gets feedback on its impact and can adjust. It's about building a framework that can learn to act responsibly and sustainably, not just efficiently. So what does this all really boil down to? We see how meta-temporal coordination offers this meta-level orchestration for future AI ecosystems. It's about holding on to history, adapting flexibly across time and agents, integrating diverse knowledge.
Enabling collaborations that are more cohesive, adaptive, resilient.
It's exactly managing that inherent complexity of these multi-species or multi-system collectives. Now, considering all those dimensions, ecological, social, technological, here's something to think about. How might truly mastering meta-temporal coordination fundamentally reshape our approach to global ethical governance and long-term sustainability? Something for you to mull over as you navigate your own complex systems.